Yeah, we're hoping that we'll start to see a lot of these things, and ideally you'd love to find one as it's approaching the sun, because you want to have time to do all the science.
The cosmos is a shooting gallery, and it appears Mars is in the crosshairs. A colossal comet, 3I Atlas, is making its way through our solar system, and its path is raising red flags at both Harvard and NASA. The data is not just alarming, it's terrifying.
And this time the usual follow-up measurements of position and speed showed something completely different. By October 22nd, we had enough data to realize that this object wasn't from our solar system.
We're talking about an object with the potential to unleash an extinction-level event on the red planet. What many have overlooked is the comet's unusual composition and its increasingly erratic behavior. The thing nobody tells you is that this might not be the only threat of its kind out there. A threat? The story of Comet 3I Atlas begins not with a bang, but with a faint glimmer in the vast, dark expanse of space. On December 28, 2019, the Asteroid Terrestrial Impact Last Alert System, or ATLAS, survey in Hawaii, picked up a faint, fuzzy object moving through the cosmos. At first, it was just another data point in a sea of celestial observations. But as astronomers at Harvard and NASA began to track its trajectory, a chilling picture began to emerge. You see, this wasn't just any comet. This was a long-period comet, a wanderer from the Oort cloud, the most distant and mysterious region of our solar system. These comets are notoriously unpredictable, their paths easily altered by the gravitational pull of planets, and even the subtle push of outgassing as they near the sun. What truly set 3I Atlas apart was its sheer size. Initial estimates placed its nucleus at a staggering 3 to 5 miles in diameter. To put that in perspective, the asteroid that wiped out the dinosaurs is thought to have been about 6 miles across. An object of this magnitude, traveling at speeds of over 100,000 miles per hour, carries an almost unimaginable amount of kinetic energy. The thing nobody tells you is that the destructive power of an impact isn't just about size, it's about speed. And 3I Atlas has both in spades. As the data poured in, the initial excitement of discovering a new comet quickly turned to a growing sense of dread. The projected path of 3I Atlas was on a collision course with the inner solar system, and one planet, in particular, seemed to be in its sights: Mars. The initial reaction from the scientific community was one of cautious skepticism. After all, predicting the exact path of a long-period comet is notoriously difficult. But as more observatories turned their attention to 3I Atlas, the data became more and more refined. The orbital calculations, run on some of the most powerful supercomputers in the world, all pointed to the same terrifying conclusion. There was a very real possibility that in the coming years, Mars would experience an impact event of a magnitude not seen in recorded history. To put it mildly, the implications were staggering, not just for the future of Mars exploration, but for our understanding of the very nature of the cosmos. Many people are crazy about the idea of terraforming Mars, but an impact of this scale would set back any such plans by centuries, if not millennia. What many overlooked in the initial excitement of the discovery was the very real and present danger this comet posed. What could be worse than a mountain-sized comet on a collision course with Mars? A cosmic cataclysm. To truly understand the threat posed by Comet 3I Atlas, we need to delve into the terrifying science of celestial impacts. When an object the size of 3I Atlas strikes a planet like Mars, the results are nothing short of cataclysmic. The initial impact would be like detonating every nuclear weapon on Earth at the same spot, 1,000 times over. The energy released would be so immense that it would vaporize the comet and a large portion of the Martian crust in an instant, creating a crater hundreds of miles wide and dozens of miles deep. The shockwave from the impact would travel through the planet at supersonic speeds, triggering a global earthquake that would shatter the Martian landscape. But the immediate impact is only the beginning of the horror. The immense heat generated by the collision would create a fireball that would incinerate a vast area around the impact site. A plume of vaporized rock and ice would be ejected into the atmosphere, so large that it would be visible from Earth with the naked eye. This plume would then fall back to the surface as a rain of molten rock, setting the entire planet ablaze. You see, the thing nobody tells you about these impacts is that it's not the initial explosion that's the most devastating. It's the long-term environmental consequences. The sheer amount of dust and debris kicked up into the atmosphere would blot out the sun for years, plunging Mars into a deep, dark winter. What many have overlooked is the effect this would have on the Martian climate. The red planet already has a thin atmosphere, but an impact of this scale would fundamentally alter it. The massive injection of dust and water vapor could, paradoxically, lead to a temporary warming effect as a runaway greenhouse effect takes hold. But this would be a chaotic and unpredictable process, with wild temperature swings and planet-wide dust storms that would make the already inhospitable Martian surface even more so. To put it mildly, the Mars we know today would be gone, replaced by a scorched, frozen, and utterly transformed world. The data from Harvard and NASA isn't just a warning, it's a preview of a planetary-scale disaster. Is it possible that we are witnessing the prelude to the complete transformation of a planet? A race against time. Faced with the terrifying prospect of a Martian impact, the scientific community has kicked into high gear. At NASA's Jet Propulsion Laboratory and at research institutions like Harvard, teams of scientists are working around the clock to refine the trajectory of 3I Atlas and to explore any and all options for mitigating the threat. You see, the thing nobody tells you is that deflecting a comet is not as simple as it sounds in the movies. These are not solid, uniform rocks. They are fragile, porous bodies of ice and dust, held together by their own weak gravity. A direct impact with a projectile could simply break the comet into smaller, but still devastating pieces. One of the leading contenders for a deflection mission is a concept known as a gravity tractor. This would involve sending a massive, uncrewed spacecraft to fly alongside the comet for an extended period of time. The spacecraft's own gravity, though minuscule, would be enough to slowly and gently nudge the comet onto a new, safer trajectory. Another option is a technique called laser ablation, which would involve using a powerful laser to heat up a small portion of the comet's surface. This would create a jet of gas that would act as a tiny rocket, pushing the comet off course. What many have overlooked is that both of these options would require a significant amount of lead time, years, if not decades. And with 3I Atlas, time is a luxury we may not have. To put it mildly, the challenges are immense. Not only do we need to develop the technology to deflect a comet, but we also need to be able to do it with pinpoint accuracy. A slight miscalculation could make the situation even worse, sending the comet on a new trajectory that could threaten Earth. The data is constantly being updated, the models are constantly being refined, but the fundamental uncertainty remains. Many people are crazy about the idea of humanity becoming a multiplanetary species, but the threat of 3I Atlas is a stark reminder of just how fragile our foothold in the cosmos truly is. We are in a race against time, and the stakes could not be higher. Could our efforts to save Mars inadvertently put Earth in even greater danger? What really happened to 3I Atlas? Just as the world was coming to grips with the terrifying threat of comet 3I Atlas, something strange and unexpected happened. In early 2020, astronomers noticed that the comet was beginning to dim. Over the course of a few weeks, it faded from view, its once bright coma and tail disappearing into the blackness of space. The initial data suggested that the comet had disintegrated, its fragile nucleus breaking apart under the increasing heat of the sun. But as scientists at Harvard and NASA looked closer, a new and even more unsettling possibility began to emerge. You see, the thing nobody tells you is that comets don't just vanish without a trace. What many have overlooked is that the disintegration of a comet should produce a large and easily detectable debris field. But with 3I Atlas, there was nothing. It was as if the comet had simply cloaked itself, disappearing from our view. This has led to a flurry of speculation and a host of new, and in some cases, truly bizarre theories. Some scientists have proposed that the comet may have undergone a process known as mantling, where a thick layer of dust and organic material has coated the surface, preventing the ice from sublimating and forming a visible coma. Others have suggested that the comet may be composed of some exotic material that we have yet to encounter. To put it mildly, the disappearance of 3I Atlas has only deepened the mystery. Is the threat over, or has it simply become invisible? Could the comet still be on a collision course with Mars, a silent, dark harbinger of doom? The data is inconclusive, the experts are divided, and the fate of the red planet hangs in the balance. Many people are crazy about conspiracy theories, but in the case of 3I Atlas, the truth may be stranger than any fiction. We are left with more questions than answers, and a chilling sense of unease about what may be lurking in the dark, unseen corners of our solar system. Whispers in the dark. The official story is that Comet 3I Atlas simply fell apart. A fragile visitor from the outer solar system that couldn't handle the heat as it approached our sun. It's a neat, tidy explanation that fits most of our models. But there's a problem, a huge one that scientists don't like to talk about publicly. When a comet that size disintegrates, it should leave behind a massive trail of breadcrumbs, a spectacular cloud of dust and ice debris. But with 3I Atlas, there was next to nothing. It didn't just break up, it vanished. And when the science can't explain the data, that's when you have to start looking at possibilities that exist on the fringes, in the whispers between astronomers late at night. The thing nobody tells you is that we assume we know what we're looking at. We see a fuzzy ball of ice and dust, and we call it a comet. But what if 3I Atlas was never a comet to begin with? One of the most electrifying theories circulating in the scientific underground is that Atlas was, in fact, an artificial object disguised as a comet, an extraterrestrial probe on a long, cold journey through the cosmos. You see, a coating of ice and dust would be the perfect camouflage, a natural-looking shield to protect its technology from the harshness of space, and to hide it from prying eyes like ours. If you accept that possibility, then its trajectory toward Mars suddenly becomes much more sinister. Why Mars? Was it a scout ship sent to observe our first steps toward becoming a multiplanetary species? Or was it heading there for a reason that has nothing to do with us? Many people are crazy about the idea of ancient alien artifacts, and some theorists believe Mars is littered with them. Perhaps Atlas was on a mission to retrieve or activate something that's been lying dormant on the red planet for millions of years. In this scenario, its disappearance wasn't a natural event. It was intentional. Once it realized it had been spotted, that its cover was blown, it simply turned off the lights. It activated a cloaking device or some other form of advanced stealth technology, becoming a ghost in our solar system, silent and invisible, but still very much on its original path. To put it mildly, that's a terrifying thought. But what if the story is even bigger than that? Another, even wilder theory suggests that the disappearance of 3I Atlas wasn't its own doing. It was destroyed. What many have overlooked is the chaotic nature of its breakup. It didn't fade gracefully. It vanished abruptly. This theory proposes that we witnessed a skirmish in a silent, cold war that has been raging in our galaxy for eons. The Atlas probe, whatever its mission was detected by a rival intelligence, one that may already have a presence in our solar system. The disintegration wasn't the sun's doing. It was the result of a targeted strike from an advanced weapon. We may have just seen the cosmic equivalent of a submarine being torpedoed in the deep ocean. This would offer a chilling answer to the famous Fermi paradox, which asks, where is everybody? Maybe they're everywhere, but they're too busy fighting each other to bother with us. Our solar system isn't a peaceful sanctuary. It's a contested territory, a piece of strategic ground in a conflict we can't even begin to comprehend. Is our solar system more dangerous than we previously thought? Let us know your thoughts in the comments below. And if you want to stay up to date on all the latest space news, be sure to like and subscribe.